Students, this is MJ Kishore, Associate Professor, Kallam Harnath Reddy Institute of Technology, Department of Civil Engineering, Environment Engineering 1, 2nd BTech, 2nd semester, R19, as per JNTU Kakinada, Lecture 17. In Unit 2 itself, we are going to discuss pipe joints, design aspects of pipelines, laying of pipelines. So, these three topics we are going to cover. Pipe joints. For the facilities in handling, transporting and placing in portion, pipes are manufactured in small lengths of 2 to 6 meters. So this generally pipes will be 2 to 6 meters because this 2 to 6 meters of pipes should be transported and should be handled and should be placed particular portion. I mean say it should be carried and kept, so that in general 2 to 6 meters the pipe length will be there, small lengths. The small pipes of the small pieces of pipes are then joined together after placing in portion to make one continuous length of the pipe. So all these small pieces we are going to keep it as a single pipe, and it's going to be larger, I mean say larger length. The design of these joints mainly depends on the material of pipe, internal water pressure and condition of the support. Nothing but depends, I mean say what is the length of the pipe and how we are going to decide itself by material of the pipe and internal water pressure we are going to consider, and type of joint we are going to keep. The bell and spigot joints using lead as filling material is mostly commonly used for the cast iron pipes. For steel pipes, welded, riveted, flanged or screwed joints may be used. So what is mean by this spigot joint and bell joint? And I think so you are familiar with welding, riveted and flanged and screwed. But this spigot joint and bell joint we are going to see in the next coming slides. So now we are going to see various types of joints. So these are the various types of joints, and each and every joint there is an example picture and in detail notes about each and every joint. First one is spigot and sprocket joints or bell and spigot joints, expansion joints, flanged joints, mechanical joints, flexible joints, screwed joints, collar joints, AC pipe joints. So each and every joint we are going to see right now. So first one, spigot and socket joints. These types of joints is mostly commonly used for cast iron pipes. For the construction of this joint, the spigot or normal end of one pipe is splitted splitted in sprocket or bell mouth end of the other pipe until contact is made at the base of the base of the bell. So here you can see we are going to cut, I mean say we are going to make a small edge. So here you can see this both will be equal, and the shape internal it goes like this. So it's going to come and joint till here. So from here till here it will be covered. So it's the opening. So this is called as bell opening. Okay. So here also you can see this is the bell opening. I mean say sectional. AB section. This is a sectional view. Here it's present. Okay. After this, hemp or yarn is wrapped around the spigot end of the pipe and is tightly fitted in the fitted in the joint by means of yarning iron up to 5 centimeters depth. Nothing but imagine this is the spigot joint. Wrapped means we are going to wrap like this. Okay. So we are going to wrap by iron, okay, yarning iron, and 5 centimeters depth we are going to close it. So the hemp is tightly packed to maintain a regular annular space and preventing joining materials from falling inside the pipe. After packing of hemp and gasket of the joint, I mean or joint runner is clamped against the outer edge of the bell. So outer also we are going to clamp as because it should not have any leakages and this joint should not again divide. Okay. Similarly, sometimes wet clay is also used to make tight contact between the runner of the pipe so that hot lead may not run out of the joint spaces. The molten lead is then poured into the V-shaped opening left left in the top by the clamp joint runner. So whenever we are going to fix it, whenever we are going to fix the particular joint, we are going to wrap, and we are going to keep a iron also has a clamp, and while keeping this both in, we are going to wrap it with the lead. So where the lead is kept in between this particular joints, we are going to use the particular clamp for the running itself. Okay, so the joint will not be means it will be tight, it will not come out of it. The space between the hemp yarn and the clamp runner is removed. The lead while shrink while cooling is again tightened by the means of the chalking tool and hammer. Nowadays, in order to reduce the cost of the lead, certain parented components of the sulfur and other materials are filled with these joints. So in the olden days, we have used this lead for the joining in between. Right now, some other materials came, because if at all we are using the lead, due to heat and cooling, it's going to we are going to have a gap in between this particular clamp. There will be gap, so that nowadays some components like sulfur and other materials are being used for the filling the joints. So there is a small video where showing the spigot joint and socket joint. So you can see clearly how the particular spigot and socket joints are present, and generally we use for this spigot and socket joints where the water pressure is more.
The socket joint as an alternative to the proven welded joints for simple and cost-effective pipe laying. This joint is designed for operating pressures of up to 40 bar.
Expansion joints. The joint is used at such places where pipe extend or contract due to the change in atmospheric temperature, and thus checks the setting of thermal stresses in the pipes. In this joint, the socket end is flanged with the cast iron following ring, which can freely slide on the spigot end or plain end of the other pipes. Similar, and inside an elastic rubber gasket is tightly pressured between the annular spaces of jockey, of a sprocket by means of bolts. In the beginning, while fixing the follower ring, some space is left between the socket base and the spigot end for the free movement of the pipes under variation of the temperature. In this way, when the pipe extends, the socket end moves forward, and when the pipe contracts, it moves backward in the space provided for it. The elastic rubber gasket in every portion keeps the joint watertight. So here you can see this is the particular joint, and this is the rubber gasket, and whenever these two pipes we are going to have, we are going to extend with this particular expansion joint, and it will be free as rubber gasket is present. It's going to see there will be no leakages. Next one is flanged joint. So this joint is mostly used for temporary pipelines, because the pipeline can be dismantled and again assembled at other places. This pipe in case has flanges on its both ends, cast, welded, and are screwed with the pipe. The two ends of the pipes which are to be joined together are brought in perfect level near one another, and after placing of washer or gasket of rubber, canvas, copper or lead between the two ends of the flanges is very necessary for the squaring a perfect watertight joint. This joint cannot be used at places where it has to bear vibrations of the pipe, etc. So this is the joint you can see clearly. We are going to join the two pipes with the extra joint where we are going to fit the particular joint. Here you can see outside, we are going to fix the outside, and here also in between these two pipes there is a, and we are going to use so many materials like gasket of rubber, canvas, copper or lead between the two ends of the flanges. So two ends of the flanges here we are going to use this type of materials. This flange joint is not used where vibrations are going to be present. So in some of the particular pipes, industrial where we use the pipes, vibrations will be present. If vibrations are present, we are not going to use this pipe, because of the vibration, the pipe joint, all these bolts will become loose. so we don't use. Next one is flexible joints. Sometimes this joint is also called bell or and socket or universal joint. This joint is used at such places where settlement is likely to occur after the laying of the pipes. This joint can also be used for laying of pipes on curves, because at the end of the, joint of the pipes can be laid at angle. This is a special type of joint. The socket end is cast in a spherical shape and spigot end is plain but has a bead at the end, other end. For the assembling of this joint, the spigot end of one pipe is kept in the spherical end of the other pipe. So here you can see one end will be plain and one end will be flexible. Nothing but the particular joint can be moved in this way. So the particular joint will move in this way. So one side. So other side it will be plain. Only one side only we can move the particular joint. So this is called as flexible joint. So in flexible joint also we are going to use this rubber socket. It's a gasket rubber. It is very clear that if one pipe is given at any deflection, the ball shaped portion will move inside the socket and the joint will remain waterproof in all the portion. So the particular small joint which is flexible, it will be inbuilt. So other joint will be remains waterproof in that all the portions. Next one is mechanical joints. This type of joints are used for joining cast iron, steel or rough iron pipes when both the ends of the pipes are plain or spigot. These are two types of mechanical joints. Recesses couplings, nothing but couplings. So here you can see both sides will be plain, and where we are going to use maximum this type of mechanical joints in the iron or steel or rough iron pipes generally we use, and compulsory the both sides will be plain or spigot itself. Its essential consists of one middle ring, two follower rings and two rubber gaskets. The two follower rings are connected together by bolts, and when they are tightened, they pass both the gaskets tightly below the end of the middle ring. These joints are very strong and rigid and can withstand vibrations and sockets up to the certain limit. And these joints are mostly suitable for carrying water lines over bridges where it has to bear vibrations. So here in middle we are going to have a rubber gasket both sides, so it's going to be tightened. So because of that, the bolt which is going to be from the rubber gasket itself, so that it can bear so many vibrations. So wherever you are going to see the bridges, railway bridges, wherever in the railway bridges, if water pipeline is there, we are going to use this mechanical joints itself. So you can see these mechanical joints. Okay, so here you can see there is a gasket also, same. Okay, next one is Vitolic joint. In this type of joints, a gasket or leak-proof ring is slipped over both the ends of the pipes. This gasket is pressured from both the sides by means of half iron coupling by bolts. The ends of the pipes are kept sufficient apart to allow for free expansion, contraction and deflection. These joints can bear shocks, vibrations, etc. and used for cast iron, steel and rough iron pipes lines in exposed places. So here in this particular joint, gasket is present. We are going to oil the gasket and we are going to fix the particular ring in between the two pipes. We are, for example, these are the two pipes. Imagine these two pipes. So in this way we are going to fix the particular joint, and there will be leak proof, and for vibrations also it will not nothing will happen for the leakage. So here you can see the Vitolic joint. So here you can see the two pipes have been joined with Vitolic joint. Vitolic joint, I have kept two videos where how this Vitolic joint is joined, and it's very important. From 1919 onwards, these Vitolic joints have been processed and developed and so many for angular shapes and so many pipes. For joining the pipes, we use this Vitolic joint. So you can see the video. Next one is screwed joint. The joint is mostly used for connecting small diameter cast iron, rough iron and galvanized pipe. The end of the pipes have threads outside while socket or coupling has threads on the inner side. The same socket is screwed on both the ends of the pipes to join them. For making watertight joints, zinc paint or hemp iron should be placed in the threads of the pipes before screwing socket over it. So the two pipes will be have here, you can see the thread and This is the one more thread inside this. This is the coupling inside. So it's going to screw the pipe into it. Next one is collar joint. This type of joint is mostly used for joining big diameter concrete and asbestos cement pipes. The ends of the two pipes are brought in one level before each other. Then rubber gasket between steel rings or jute rope socket into the cement is kept in the groove, and the collar is placed at the joint. So it should have same lap on both sides the pipes. Now 1:1 cement mortar is filled in the space between the pipes and the collar. So two pipes we are going to like concrete pipes we are going to keep, and this collar joint we are going to keep, and we are going to fill with the space with the cement itself. So here you can see two pipes have been joined here, and outer layer is nothing but we are keeping the collar joint, and we are going to fill the particular joint with the cement itself. Joint for AC pipes. For joining small diameter AC pipes, the two ends of the pipes are butted against each other. Then two rubber rings will be slipped over the pipe, and the coupling will be pushed over the rubber rings. The rubber rings makes the joint waterproof. So here you can see two joints. This is the rubber ring. We can say we are going to push it into it, and it's going to be act as a waterproof also. It will not leak from the joint. Water will not leak from the joints. Design aspects of pipelines. Pipeline design includes a selection of route traversed by the pipe, determination of throughput, amount of fluid or solid transported, and the operational velocity, calculation of pressure gradient, selection of pumps and other equipment, determination of pipe thickness and material, example whether it is used as steel, concrete, cast iron or PVC pipe, and an engineer economic analysis and the market analysis to determine the optimum system based on alternate designs. So all these are the design aspects. So we should see the velocity and what type of fluid is going to be travel from the pipes, and the thickness of the pipe and material of the pipe, and we are going to see economical analysis of the market also. So it should not be more cost. In each design, careful considerations must be given to the safety, leak and damage prevention, governing regulations and environmental concerns. Okay. Laying of water supply pipes. Pipes are generally laid below the ground level, but sometimes when they pass in open areas, they must be laid over the ground. The pipes are laid in the following way. First of all, the detailed map of all roads, streets, lanes, etc. is prepared. On this map, the proposed pipelines with all sizes and lengths will be marked. The portion of existing pipelines, crub lines, sewer lines, etc. will also be marked on it. In addition to the portion of valves and other pipe species, stand posts, etc. will also be marked, so that at any time of laying there should be no difficulties in the connections. So before laying the water pipelines, we should take topography, nothing but the present existing pipelines of the map we are going to take, and we are going to roughly lay the different types of pipes which will be suitable. We are going to see economically also we should see. After general planning, the center line of the pipeline will be transformed on the ground from the detailed plan. The center line will be marked by means of circles driven on at 30 meters interval on straight lines. On curves, the stalks will be driven at 7 to 15 meter spacing. If the road or streets have curves, the distance of center of the pipeline from curve will be marked. So when the center line has marked on the ground, the excavation for the trenches will be started. The width of the trench will be 30 centimeters to 45 centimeters more than the external dia of the pipe. At every joint, the depth of excavation will be 15 to 20 centimeters more for 1 meter length for easy joining of the pipes. the pipelines should be laid more than 90 centimeters below the ground, so the pipe may not be break due to impact of heavy traffic moving over the load. So here laying of pipes, we are going to have certain dimensions of the depth, how much depth we can driven the excavation should be made for the pipe. So it in detail I have said here. After the excavation of the trenches, trenches of the pipes are lowered in it, the pipe laying should start from lower level and proceed towards higher level with socket and towards higher side. The joining of the pipe should be done along with the laying of the pipes. After laying the pipe in position, they are tested for water leakage and pressure. When the pipeline is tested, the back fillings of the excavated material will be done. The soil which has been excavated is filled in the trenches of all around the pipe and should be well ramped, and all the surplus soil will be deposited off the site, should be cleaned. So after excavation, we are going to lay the pipe. After keeping the pipe, while keeping the pipe itself, we are going to joint. Afterwards, we will not join each and every pipe. We are going to join and keep. And after completion of the pipe joining also, we should test the water for leakage and pressure test. After that only, we are going to close the excavated soil onto the pipe again. Laying of water supply pipes, you can see. I think so you are familiar seeing this outside also. In Guntur also recently they have laid pipelines. So hydrostatic test, after laying the pipes, we are going to test this hydrostatic test. After laying the new pipeline, joining and break filling, it is subjected to the following test. Pressure test at the pressure of at least double the maximum working pressure. Pipe joints shall be absolutely watertight. Leakage test to be conducted after the satisfaction completion of the pressure test at a pressure has specified by the authority for the duration of 2 hours. In this way, error in workmanship will be found immediately and can be rectified. Usually, the length to be tested is kept up to 500 meters. So, this hydrostatic test, if we are not going to do after closing the soil, the excavated soil, it will be very problematic. So that we are going to test for 500 meters this hydrostatic test. So here you can see this hydrostatic test. Okay. So here also same. It's a failure of pipe pressure. So with this, unit 2 has been completed. Nothing but types of pipes, material of the pipe joints. So unit 2 has been completed. For any queries, you can message me. Keep a message in the Google Classroom. And next lecture will be on introduction to unit 3. So unit 3 we are going to see introduction only next presentation. So for any queries, you can message me in the Google Classroom. Thank you.